Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip. In this video, I'll be talking to you about using nested loops. So we've already seen that loops, either while loops or for loops, are actually program statements. But we also know that while and for loops can contain statements in the body loop. So that means that if a while loop can contain a statement and a while loop is a statement, you can have a while loop inside a while loop. And the same for loops. So you can mix and match these. You can actually nest blocks, ifs, loops, all of these things within each other to as many levels as you like. The only thing you want to be aware of is that at a certain point, if you've got lots and lots of nesting, things become really hard to read and understand. So one of the things you want to make sure you're doing if you do nesting is to use proper indentation. Using Command-T or Control-T will help you in processing to auto-indent your code. And this is really useful when you're doing a lot of this. So the next few slides we're going to go through, I'm going to explain what nested loops look like. And I want to warn you that this can get a little bit confusing, but this is really common. So take your time and watch this as many times as you need to. I'm going to go through a lot of examples, so this video will be a little bit longer than some of the other videos. All right, so let's look at our first example. This is a nested for loop. We have a variable that we're declaring before the loops that's a count variable, and we're initializing it to 0. Then we have what we call the outer loop, and this loop is iterating over I. So it's a for loop, so we're counting over the value of I. We're starting at 0 and going up to 20. And what's inside the for loop is actually another for loop. So the inner for loop iterates over j. It has its own counter, a different variable, and it goes from 0 to 10. And what happens when j goes from 0 to 10 is that we're adding to count by 1. So this is the outer loop, and this is the inner loop here. So what happens with this loop when we run it? The computer goes step by step. So we're going to start with the first loop, and I will be 0. And while I is 0, we're going to iterate through the inner loop. So I is going to be 0, the j loop starts, j is 0, but j just goes through all its different values from 0 up to 10, and then increases count each time. Then we're done with the inner loop, and so we come back up and we're going to iterate on the outer loop, and so I will then become 1. And then we're going to repeat this whole process. So if we look at this, in this example at the end, we want to print out the value of count, and this is the variable that's being increased by 1 every time we go through the inner for loop. So the question is, what will be printed out here? What is the output? And what that question is really asking is, how many times does this loop run? And we need to know how many times both loops run, the outer loop and the inner loop. So here's the outer loop. It's sort of defined by this for header and these curly braces, and this is the body. And then we know that the outer loop is going to run 20 times because we're going from 0 to 20. Now, what about the inner loop? That's this one in here. The inner loop is going to run 10 times, and it's going to run 10 times for every time that the outer loop runs. So the I loop, which is the outer loop, iterates 20 times, and each time it iterates, the inner loop is going to iterate 10 times. So we have to actually multiply these things together. So what that means is that count is actually going to be 200, because we're going to execute this line 200 times. We're executing it 10 times every time we do this, and we're doing this 20 times. So in general, when we have nested for loops, you can look at how many times each of them will iterate, and you can multiply it to figure out how many times the body of the inner loop will execute. And that's usually a pretty good rule of thumb, although if the number of times the inner loop executes is actually somehow tied to the outer loop, if the variables are actually tied together, then that could be different. So let's look at a base case here and look at what this prints out. So we've got a smaller loop here that doesn't iterate quite as many times. Here our outer loop goes from 0 to 3, and the inner loop, which is using the j, is going from 0 to 5. So you should now be able to know that this println statement in here, which is printing out I is and the value of I and J is and the value of J, that this should actually print out 15 times because we multiply these together. So what does it look like? The output looks like this. We're going to have I is 0 and J is 0, I is 0, J is 1, I is 0, J is 2, I is 0, J is 3, I is 0, J is 4. So that's one iteration of the outer loop and the 5 iterations of the inner loop while the outer loop is set at I is 0. And then once we've done that, we're going to come back up. I is going to change. It's going to become 1. And you see that we go through and J goes through all its values again while I is 1. And then we're going to do it one more time because I can go up to 2. And J will iterate through all of its values while I is 2. And that's the 15 println statements. Okay, so doing println is fine, and iterating over values and counting numbers is okay. But of course, we're using processing, and that's more fun because we can draw things. So let's look at this example. And how would we go about drawing this big grid of dots? These are perfectly evenly spaced dots. They fill our canvas. And so we want to think, how do we even think about approaching this problem? And the way that I would do this is I would start by using a for loop to draw like a series of dots that goes across the screen. Just try to get sort of one part of this. So if I could just get this top line of dots, that would be a sort of a first start at getting this to happen. And so there I would do a for loop, and I'm going to have a couple of constants: the circle size, the size of my dots, the spacing, which is, the number of pixels from the center of one dot to the center of the next dot. And I'm going to just do a no stroke, make these dots not have an outline. Now my for loop is going to iterate, and I'm going to have a variable that I'm calling x position, and it's an integer. And I'm going to start it at spacing. I could start it at 0, but then I'd have dots that were right on the edge of the canvas. So I'm going to start it at spacing. And then I'm going to increase it by 20 each time. And then I'm going to make this so that we keep on increasing the position until the position is greater than width, and then we're going to stop. And then I'm going to actually draw this ellipse at x position, and spacing, which is going to be how far down I am. So I'm 10 over and I'm going to be 10 down. So all of these top dots are 10 down. And then there's my circle size. And so this will draw a bunch of circles spacing down across the screen. The first one will be at spacing. The next one will be at spacing plus 20 because I'm incrementing by 20. The next one will be at spacing plus 40, etc. So that's how I get dots across the top of the screen. So that's a start on my grid. Now, I also know that I could do something similar to draw dots down the canvas. So I could change this, and I could change it to iterate across y position. And again, using spacing and going until the height, before I was going into the width, and again, iterate, increasing the value of y position each time. And with this code here, spacing, the x coordinate for my ellipse is spacing, the y coordinate is this y position, which is changing each time through the loop. And that would allow me to draw these dots down the canvas. So what I want to do now is combine these two things. And the way I'm going to put these two things together is to have these nested for loops. So my outer for loop is going to iterate across y position. And so y position is changing, which means I'm going to be moving down the screen. And then my inner for loop is iterating across x position. That's going to be changing, which means in the inner for loop, I'll be moving across the screen, drawing the dots along the row. And then my ellipse now, instead of having either the x coordinate or the y coordinate be static, both of these are dependent on how these loops are iterating. So what does this actually do? The outer loop is iterating down the screen, changing the y position. So when we start this, we're going to start at the top. The inner loop is then going to iterate across the screen and draw the first row. So Y position is spacing, and X position is going to change, and we'll get the first row of dots. And then once we're done, Y position is going to increase by 20. So we're going to come down here, and then we're just going to do the same thing again. X position is going to be back at the beginning again, and we're going to iterate through the inner loop and go across and draw the second row of dots. And then we just keep on going, and we're going to do this until Y position actually is bigger than height. At that point, we'll stop our loop. So that will allow us to fill our screen both horizontally and vertically with these dots. We could also switch this around. So we could put the X position in the outer for loop, and in this case, and then the Y position in the inner for loop. In this case, what we would be doing is the outer loop is iterating across the screen, changing the X position. So the first time we do this, we're here, and the inner loop is iterating down the screen. So in this example, what we do is we come here and we draw the first column of dots, and then X position increases, so we move over one, and then we do the inner loop again, we draw the second column of dots, etc. And we repeat to fill the screen. Okay, we could add some color changes in here to just sort of make this a little bit more interesting. So we could change the amount of blue and red. And so in this example, we've got the same code, but we've added red, green, and blue variables up here. And then every time we move a little bit across in the X position, we're going to increase the red by 10. So we started with our red value at 0, and we're going to increase the red by 10. And this is going to come in here. We've got a fill command now right before our ellipse statement. And so you can see if you look across here just at the first row, as we move from the left to the right, we've got more and more red. Now, every time we do this, we're also going to reset blue to 0, and we've moved a little bit across here. So say we've done this once, we move this little bit across here, we're going to, on our inner loop, we're going to be moving down. In our inner loop, every time we iterate, we're increasing blue by 10. So you can see here that the blue gets brighter and brighter as we move down towards the bottom of the screen. And as we combine this, what happens is we're getting redder and redder this way, we're getting bluer and bluer this way, and so as we get down to the bottom right of the screen, we're getting both bluer and redder, and so we're getting these purple dots as we move down to the bottom right of the screen. So this is just an interesting way of making use of our for loops to make these gradual changes and increment things. All right, so I'll leave this challenge to you to do at home. What about making the dots that are further to the right a little bit bigger, like in this example? And I'm not going to show the code for that. You can try that out. So one other thing that we can do here is that we can make our inner loop dependent on the outer loop. And that's shown in this example where we have this dot grid that is not filling the entire screen. It's only filling the screen partially. And I want to show you what the code looks like to make this happen. So again, we're still using the colors in here, but what I really want to point out is that in this case, we have our outer loop, which is iterating across Y position. So we're going down the screen, and the inner loop is iterating across from left to right. So in the first time we go through our outer loop, Y position is going to be spacing. It's going to be 10. We're going to be right here. And the second time, Y position will be 10 plus 20, will be down here. So we're going to move down. The inner loop is going across, iterating X position. We're starting at spacing, but what's changed is this condition right here, the stopping. So we're going to keep on going each time we do the inner for loop until X position is greater than or equal to Y position. And X position and Y position, they're equal at the diagonal line. And so what this means is the first time we come in, an X position is actually we're not even going to do the inner for loop the very first time because X position is actually equal to Y position. They're both spacing. The second time when we've done the outer for loop and Y position is then, 30, then X position gets set at 10 and we do this one dot and then we don't do another dot because now y position is 30, x position is 30, we don't do that one. And so then the third time through, we're going to do a little bit more. Y position is a little bit bigger, so x position we'll be able to draw a couple more dots, etc. And so in this case, the inner loop and how many times it iterates for each time the outer loop iterates actually is dependent on the value of the outer loop counter variable, y position. So that's a little bit more complicated than just having them be completely independent of each other. All right, here's another example. We can actually make these things interactive, of course, with processing. So if we take our script and we make it active by adding in a void setup function at the top and then putting our drawing stuff inside of a void draw function, we can start to do some interesting things here. So what we want to do in this case is we want to make one of these dots red if it's near the mouse pointer. And we want it to look like this. So here, as we're hovering the mouse over, the dots change color and they can become red depending on if the mouse is really close to them. So how do we do something like this? Well, we can actually put an if statement inside our innermost for loop, and that's what we've done here. So this is the same for loop as we saw before with y position in here in the inner loop so that we're getting that triangle of dots, not the full grid. But inside this for loop, we actually have an if statement that's testing the distance from the mouse pointer to the current dot that we're drawing. And if it's less than spacing, which was I think 10, then we're going to actually fill the dot with red, and otherwise we'll fill the dot white. And then we draw our dot. And so as we're drawing this, we're checking to see if the dot that we're just about to draw is close to the mouse cursor and filling it with red. So you can put if statements inside of these nested for loops. It's not a problem, works perfectly fine. Here's another version of making it interactive where instead of doing two for loops, we're actually doing an outer loop that's dependent on where the mouse is. So this time, how far we're drawing in the one direction is dependent on the where the mouse X, the sort of horizontal position of the mouse pointer. So let's have a look at what this looks like. So as we move to the left, we're drawing fewer, a sort of a smaller grid. As we move to the right, we're drawing a bigger grid. And that sort of changes how far down we're drawing based on this Y position. So you can try out things like this as well. Okay, the last example I want to look at is an example that's not so much drawing as it is using text. And so we've been working with strings a little bit, and you know that strings are just a series of characters. And so one thing that's fun is once we start using for loops is we can iterate across the strings and do some interesting things. So for example, we could iterate across a string of characters and reveal that by drawing a character at a time or more and more characters. And so this image right here, which takes the phrase computer science and at the top just draws the C and then the CO and then the COM, etc., is created by this code here. And so we'll just go through this quickly. So this gives us an option pane, and we're going to get a word or phrase from the user. It's going to be stored in S. And we've got some stuff here to set up the text size and our text color and a background of black. And then in our draw function, we are going to have a for loop that iterates and just moves across the screen using the spacing variable, or sorry, constant, which is 30. So we're just sort of slowly moving across the screen. Y position, we're moving down the screen. And then our inner for loop is iterating not by position, but it's iterating across the length of the string. So we start at 0, and the first time we're actually going to do this to make sure that we don't go too far, and then we're never going to go further than the length of the string. So then we're going to get the character at this iterating variable I, and we're going to print it out at X position and Y position. And so because we don't have two for loops that are iterating X and Y, we've only got the for loop that iterates Y position, we actually have to do the X position iteration or incrementation here. And so we're taking the min here of the Y position divided by the spacing or the length of the string, and that's allowing us to get only a little bit of the string each time so that we don't show the whole string each time we move down the canvas. Okay, so that's a bunch of examples of using nested loops, and you can look at those code, try and type them in, play with them, because this stuff will take a little bit of getting used to. It can be a little bit confusing when you've got loops nested inside each other. All right, thanks for watching.